My name is Sarah Raimi, and I worked on the Towards Blockchain Interoperability with Hyperledger project. I'm currently located in Toronto, Canada, and I'm a master's student at the University of Alberta, which is located in Edmonton, Canada. I had the opportunity to work with Professor Rui Cruz, Rafael Volcher, and Sarah Rouhani as my mentors during this project. In this project, I used different Hyperledger technologies such as Fabric, Bezu, Caliper, and Explorer. I'm going to first start with why blockchain interoperability is important. So in the past few years, we have seen a lot of blockchain networks being created around the world. All of these networks are working isolated from each other. Now imagine if we could transfer data and information between these networks, then we could come up with a lot of new innovating technologies and applications for the blockchain. So in this project, we wanted to answer two research questions. One, how can we interoperate Hyperledger technologies with other blockchains? And two, what are the main design principles of a blockchain interoperability solution? So the project objectives were to design a blockchain interoperability solution that can be used by Hyperledger technologies, implement a proof of concept for the design, compare with other interoperability solutions, and write a research paper. The project deliverables were the system design documents, code for the implemented proof of concept, technical documentation, and the research paper. So I've already delivered all of these except for the research paper, which is in its final stages. So our idea was to use the publish-subscribe architecture to enable interoperability for blockchains. Imagine a source and destination network that want to work together. We call the source network the publisher and the destination the subscriber. Our idea is to have a broker blockchain in the middle that keeps track of the communication information, and also it keeps track of the data and information that wants to be transferred. The data is stored on the broker blockchain as topics. So what happens is that the publisher network comes in and enrolls as a publisher in the broker blockchain, and then it creates a new topic. When a topic is created, every other blockchain network can come in as a subscriber and subscribe to that topic. From that point on, every time the publisher network updates that topic, all of the subscribers will be notified of that change. All of our code and documentations are available on Hyperledger Labs GitHub page. You can scan the QR code here on this page to go to that link. So we implemented the broker blockchain using Hyperledger Fabric version 2.2. We used Hyperledger Caliper to analyze the performance of our network, and we used Hyperledger Explorer to monitor what's happening in the network. We implemented an example publisher network using Fabric version 2.2. We also implemented 2 example subscribers using Fabric version 1.4 and Hyperledger Bezu. So I have prepared a demo here for you to see how the network works. I'm just going to make sure that it has a good quality. Okay. Okay. So here you can see the Hyperledger Explorer page for the broker blockchain. It shows that we have 11 transactions and 11 blocks. In this window, you can see 4 windows. The top left one is the broker blockchain, the bottom left one is the publisher, and the 2 right windows are the subscribers. The top one is the Fabric subscriber, and the bottom one is the Bezu subscriber. So what we want to do first is that we want to query the publisher and the broker to see whether we have any topics on the network or not. So right now, we don't have any topics. So what we want to do is to go to the publisher, and on the publisher, create a new topic. So we give it a name and a message, which here is initial message. And what we do, we query the blockchain again to make sure that it was actually created. So we can see the topic here. If we query the broker blockchain as well, we can see the topic has been created with a unique key, and it also has a list of subscribers, which is currently empty. So what we do, we want to subscribe to this topic from one of our subscribers. So we first make sure the topic does not exist there, and then we subscribe to the topic. Now, if we query the subscriber again, we can see that the topic has been created with the same message and the same name. And if we query the broker, we can see that blockchain 0, which is our Fabric subscriber, has been added to the list of subscribers. We want to do the exact same thing for our Bezu subscriber. We make sure that the topic does not exist on the blockchain first, and then we subscribe to the topic, which again creates the topic on the subscriber and also subscribes to the topic on the broker. So we see that it has been created here. And if we query the broker, we can see that blockchain 1, which is our Bezu subscriber, has been added to the list of subscribers. So the next step is to publish a new message to the topic. So we update the message to new message. And we expect that all of our other blockchain networks get notified of this change. So if we query the broker again, we can see that the topic has been updated to new message, and the same thing happens for both of our subscribers. And if we go back to the Hyperledger Explorer page, we can see that the number of transactions and blocks were updated. So I mentioned earlier that we use Hyperledger Caliper to analyze the performance of our network. What we did was that we changed the transaction send rate throughout time, and we monitored the throughput and the average latency for different functionalities that our broker supports. The functionalities are publish to topic, subscribe, unsubscribe, query, and create. So there are a lot of details here in this plot that I don't want to get into, but the most important thing that we understand here is that the bottleneck of our network is the publish to topic function. So my recommendations for future work are first to add support for other permission blockchains. Right now we support Fabric and Bezu for interoperation. We could definitely add other permission blockchains here. And my second recommendation is to add an access layer control, an access control layer to the network that enables us to control who can access which topic. The third recommendation is to enhance the performance. Excuse me. I mentioned earlier that the publish to topic function is the bottleneck of our network. So we can definitely work on improving that to enhance the performance of the whole network. Finally, this project can possibly be integrated with Hyperledger Cactus in the future. What I learned about open source was first that you need to do your research. So each open source project is different from the other ones, and you need to first understand what's happening in the project to be able to contribute effectively. And then always ask questions. If you're stuck on something, reach out to other people that are working on the same project and ask your question. I've understood that people want to help you, and they definitely will if they can. Finally, I believe even the small contributions in open source can teach you a lot. Even if you have changed a few lines of code, those lines of code are going to be reviewed by professionals, and they're going to be giving you feedback on your code, which is a great learning opportunity. Thank you so much.